We'll be starting with this new chapter on corrosion, and let's start with the basics of what is corrosion and why is it so important, and then we'll move on towards the understanding of the corrosive capabilities of different materials, and then the corrosion rates, corrosion types. So let's start with the very basic of what is corrosion. Corrosion is basically defined as the destructive and unintentional attack on a metal, and it is basically electrochemical in nature, which begins at the surface. Very basic in nature. That means it's a destructive attack on metal, which normally initiates at the surface of the material. Further, it says that it's a natural process and it returns the metal to its oxidized state or combined state in the form of chemical compounds that are similar to the minerals from which they are extracted. So normally, most of the metals, they do not exist in the elemental form. They are basically extracted from different compounds into the metallic state by performing certain processes. So corrosion, if you look at a very crude form, it's the natural process of metals trying to get back to their original state, or their initial state, the state they were there in the uh, in the very basic form. All right, so it's that process. Now, if you look at this car body, it's an automobile that was made up of plain carbon steel. Now you could recall the plain carbon steel. It only has iron and carbon, iron with a small amount of carbon into it. That at one time was painted is rusting away in the field. The paint was there to offer a protection. It was there to protect steel from getting back to its original state. Original state is a chemical form or a compound from which the steel was originally extracted. So, although the paint offered a limited protection, but it was not enough for a longer duration of time. And why you painted the body? Because the process begins at the surface. So you had to protect the surface in order to retain the automobile in the form of plain carbon steel. But you could still have examples. For example, a Ford sedan that was unpainted, but it was made up of stainless steel. When I say stainless, stainless means it's a product that is uh, corrosionless, that protects its surface from getting stained. So it's corrosion resistant steel, and this was prepared so that you don't have to apply a protective covering in the form of paint in order to protect the body from the corrosion process. But you don't get such bodies because stainless steels are much more expensive as compared to the plain carbon steel. Now, what is the importance of corrosion? The metallic corrosion is such a significant problem that for an industrialized nation's income, approximately 5% of the income is basically spent on either preventing corrosion, or it is being spent on the maintenance or replacement of the products which are lost or contaminated as a result of corrosion reactions. It's such a huge problem. And if we want to analyze the relevance of corrosion with regards to our daily life problem, it could be as simple as the rusting of this bicycle that may be there at the corner of your streets, to as dangerous as the falling of Silver Bridge, which was connecting Ohio and West Virginia in 1980s, in 1967, due to the corrosion of uh, the components which were holding the bridge, or as for in August 2000, the natural gas pipeline explosion that resulted in several deaths was again associated with the corrosion of the pipeline, and the pipe was not able to bear uh, the internal pressure that resulted in the explosion. Again, this could be very simple, or it could be it could lead to a very catastrophic failure. This is the general overview of what is corrosion and how important it is. But when we come to material science, we define corrosion is a process which is electrochemical in nature. That means a chemical reaction is there along with the transfer of electrons from one chemical species to another. So how do you define corrosion? Corrosion process, you say that there are basically a corrosion process requires a complete corrosion cell and circuit, which includes these four components. So presence of anode, cathode, electrolyte, and electrical path. These four components are necessary for corrosion to take place. And we'll look into these components one by one. Here you have at the bottom right corner of the screen, you have the electrochemical cell. We'll first look into what is anode. Anode is the part of the corrosion cells where metal atoms characteristically lose or give up electrons in what is called is an oxidation reaction. The site at which oxidation takes place is called the anode, and oxidation reaction is also known as the anodic reaction or the corrosion process. And what are the typical reactions that result in the corrosion reaction or the anodic reaction? You have an anode over here, zinc, and zinc is basically converting into ionic form by losing up two of the electrons. So losing up of electrons is the characteristic that results in the oxidation reaction. The general form of the reaction is where M, which is in the metallic form, goes into the ionic form by losing up the electrons. So it is giving off electrons. For example, zinc going to Zn2 plus, iron going to Fe2 plus, aluminum going to aluminum 3 plus by giving up 3 electrons, or even the ionic form of Fe2 plus giving up another electron and converting into plus 3 form is again the ferrous ion oxidation. It's again an oxidation process that is taking place at the anode. All right. So far, is it clear?
Yes,
Yes,
sir.
sir.
All right.
Yes, sir.
Great. Now, moving on to the second half of the or second component associated with this electrochemical cell is that the electro is the cathode. And how do you define a cathode? The electrons generated from each metal atom that is oxidized must be transferred to the cathode. This is the one thing, and become a part of another chemical species in what is termed as a reduction or cathodic reaction. So the utilization of electrons generated by anodic reaction and resulting in the development of another chemical species is basically a reduction reaction. This is the place where reduction reaction is taking place. This is your cathode, and what is happening is electrons that were generated over here with the help of the electrical path, they reached up to the cathode. And what is happening at the cathode? At cathode, you have this reaction taking place. That means ionic form, utilization of electrons, reducing valency. So copper ions converting into copper metals by consuming the two electrons that were generated by the zinc atom. If you see why is it a reduction reaction, it is basically the reducing or the reduction of the valency that basically is synonymous with the word reduction reaction. Now, there could be many types of reduction reaction, and these reactions, the equations for these reactions have been listed for you. You have to remember these equations with regards to the environment that is there. You have to memorize these equations. This is the oxidation reduction reaction that is taking place in neutral or basic environment. Similarly, if the oxygen evolution is taking place, oxygen reduction is taking place in acidic environment, you'll use this reduction reaction. Evolution of hydrogen gas in water bases, this is the reduction reaction. And hydrogen evolution in acidic environment, this is the reduction reaction. Similarly, the opposite of the ferrous ion oxidation reaction is the Fe3 plus converting into Fe2 plus. This is metal or ferric ion reduction reaction. Clear enough? Is this clear so far?
Yes, sir.
All right, great. Now you have looked into these two components, anode and cathode. The electrolyte, the presence of this light blue electrolyte where you have the ionic solution of zinc ions and copper ions, it is necessary to complete the electrical path. If you won't have this ionic solution, you would not have the electrical path available to you. So electrolyte is necessary, and in order for the electrons to move from the anode to the cathode, again you need to have an external path that basically governs the condition of electrical path. So presence of electrolyte for the ions and presence of electrical path to complete the circuit, this is necessary for the corrosion reaction to propagate. All right, it's it's not just the anode and the cathode, these two components are necessary for the process to take place. All right, electrochemical half and full reactions. An overall electrochemical reaction must consist of at least one oxidation and one reduction reaction. For example, if we say zinc metal immersed in acidic solution containing H plus ions. Now, the acidic environment and presence of H plus ions, they are defined for you so that you could write the reduction reaction, because there are different kinds of reduction reaction that have been discussed with you. Presence of zinc metal, again, zinc metal going to Zn2 plus would require losing up of two electrons. This is the anodic or oxidation reaction. As for the reduction reaction or cathodic reaction, you need to have, there are many possibilities, but depending upon the environment, you will define the uh, reduction or cathodic reaction. If you see over here, this is the reaction that takes place when you have hydrogen evolution in acids. Presence of H plus ions and acidic environment would lead to this reduction reaction. So essentially what is happening at anode, you have zinc going to Zn2 plus, and at cathode you have evolution of hydrogen gas from the H plus ions. These two half reactions are taking place. Now if you notice in both the reactions there are two electrons that are being involved. It says that there could be no electrical charge accumulation from the electrons and ions for the overall electrochemical reaction. That is, the total rate of oxidation must equal to the total rate of reduction, or in other words, all the electrons that are generated through oxidation, they must be consumed by the reduction for the overall electrochemical reaction. If no other oxidation or reduction reactions occur, the total electrochemical reaction is just the summation of the two reactions, the anodic and cathodic reaction. So what you'll do is that you have essentially added the two, electrons would cancel out, and you'll have zinc going to Zn2 plus and hydrogen ions converting into the hydrogen gas. This is the overall electrochemical reaction that is taking place. Now, another example of oxidation reaction or oxidation process is the rusting of iron in water, which contains dissolved oxygen. Now, rusting of iron, you understand that iron converting into the ionic form. What should be the reduction reaction? G, any idea?
सर ऑक्सीजन आयरन के साथ ऑक्साइड बना देगा ना?
अभी सिर्फ मुझे हाफ रिएक्शन की बात करें कि
अ,
ये तो समझ आ रहा है कि आयरन जो है वो आयनिक फॉर्म में चला जाएगा, +2 या +3 की फॉर्म में चला जाएगा। इस स्टेटमेंट को देख के व्हाट डू यू अंडरस्टैंड कि व्हाट शुड बी द रिडक्शन रिएक्शन?
सर ऑक्सीजन अपने उसमें नहीं चला जाएगा O-2 वाली जो स्टेट है?
सर
अच्छा,
ऑक्सीजन
अब लेट्स फर्स्ट डिफाइन द एनवायरनमेंट। पहली
सर
चीज, जी जी,
सर वाटर प्रोड्यूस करके इसके इलेक्ट्रॉन्स प्रोड्यूस होंगे उसके।
अच्छा चले ये देख लेते हैं। ये बताएं मुझे कि स्पीशीज कौन सी इन्वॉल्व होंगी?
सर हाइड्रोजन आयंस।
अच्छा, सबसे पहले तो ये डिसाइड कर लें कि इज इट द रिडक्शन ऑफ ऑक्सीजन और इज इट द एवोल्यूशन ऑफ हाइड्रोजन? Environment में if it is being said that dissolved oxygen is there, so dissolved oxygen means that you have either this reduction reaction taking place or this reduction reaction taking place. Oxidation reduction is there. Now, since the environment is neutral or you have water in the environment, you will have oxygen converting into OH ions. This is the reduction reaction that we'll be looking into. All right. So if we had combined the two reactions, what is happening? Iron is converting into Fe2 plus and oxygen gets converting into OH ions. Together they could form the FeOH2 precipitate. Further, this Fe2 plus further reduction of oxygen results in the formation of Fe2 plus to Fe3 plus. And this Fe3 plus is basically the insoluble compound, non-metallic, the non-metallic insoluble com compound that is being formed with the non-metallic elements, and this is the reddish brown rust that you see on your everyday steels. All right, FeOH3. Clear enough? It's a double oxidation reaction that is taking place. Is this point clear? Are you guys with me?
Yes, sir.
All right.
Yes, sir.
All right. Now, moving on towards the potentials associated with electrodes. It says that not all metallic materials oxidize with the same degree of ease. हर मेटल उतनी आसानी से कोरोड नहीं होता जितनी आसानी से कोई और मेटल होता हो. So how do you define that a metal gets corroded easily as compared to another metal? For instance, if you have pure iron, which is immersed in its own ions having 1 molar concentration. Forget about the concentration at the moment, but just imagine iron being immersed in its own ions. Similarly, a copper electrode or copper which is being immersed in its own ions of 1 molarity, but both of them are immersed in their own respective ions. And the cells have been separated by a membrane which limits the mixing of two solutions. So you have iron over here, which is immersed in its own solution of 1 molarity, and copper, which is being immersed in its own solution, 1 molarity. So, two metallic strips are there. You have the electrolyte, and you connect them via external wire. So, you have basically both the electrodes present, the electrolyte is there, and the electrical path is there. Now, if you look at the figure, you would see that iron is converting into Fe2 plus. It's reducing, reducing in thickness. In other words, this is oxidizing, and copper gets deposit on copper. That means it is undergoing a reduction reaction or a cathodic reaction. Clear so far?
Yes, sir.
The problem
It's
is, why is it so that iron is oxidizing and copper is reducing? Why isn't the other way around? It
Sir,
is
cell potential.
basically G cell potential. It is basically the tendency of certain metals to get oxidized as compared to the other metal. So we have seen that as a result of this connection, copper ions will deposit, electrode deposit as copper on the copper electrode, and iron would dissolve or corrode on the other side of the cell and goes into the solution as Fe2 plus. Right. This is the overall reaction. Cu reducing, iron oxidizing. You refer to this as a galvanic couple. A galvanic couple is when two metals electrically connected in liquid electrolyte, in which one metal becomes an anode and corrodes while the other acts as the cathode. Galvanic couple किस चीज को कहते हैं हम when two metals are connected in an electrolyte, electrical electrolyte मौजूद है, और जाहिर ही बात है when they are physically connected, so you don't need to have these wires present. Connection is already there, the external connection, and due to the presence of the electrolyte, if one metal becomes the anode and other becomes the cathode, you call it as a galvanic couple. Electric potential or voltage exists between two cells, and you see that at 25 degrees centigrade, the copper iron galvanic couple gives you a voltage of 0.78 volts, again at 1 molarity concentration. So various electrode pairs have different voltages. The voltage is the driving force for the electrochemical oxidation reduction reaction. In other words, materials may be rated as compared to the tendency to experience oxidation when coupled to other metals in solutions of their respective ions. So you have two conditions. Number one, the molarity is fixed, 1 molar concentration of its own ions, and the temperature is fixed. For this condition, you can develop the tendency table. That means you can find out the standard half cell potential, pure metal electrode immersed in its own ions of 1 molarity at 25 degrees centigrade would give you would help you find out the electrode potential. The important thing is you need for the voltage, for finding out the voltage, this half cell should be connected to some other cell so that you could have a comparative voltage. Isn't it so? किसी भी मेटल के पोटेंशियल के लिए you need to have a reference जिसके against वो potential find out किया गया हो. So what you create is that you develop an electromotive series which is the standard half cells of various metals against standard hydrogen electrode. So this is the reference electrode against which all the metals are being compared for the voltages, and they are being ranked as compared to the voltage of hydrogen. Hydrogen electrode है क्या? Hydrogen electrode is basically arbitrarily chosen reference cell है, और उसमें होता क्या है कि you insert platinum electrode in 1 molar concentration of H plus ions, and you have hydrogen gas that is bubbled through the solution at 1 atm and 25 degree centigrade. So basically you have both, ये एक surface मौजूद है platinum की, और इस surface के surrounding में you have presence of both H plus ions as well as H2 gas. So this could go either way. H plus could convert into H2 gas, or H2 could convert into H plus ions, depending upon which reaction is taking place, whether it is the reduction reaction taking place or the oxidation reaction taking place. You have both these species present in the atmosphere, and platinum electrode is an inert electrode which is used as the surface only. It provides the surface for the reaction. So the platinum itself does not take part in any electrochemical reaction. It is acting as a surface on which H2 atoms may be oxidized or they may be reduced. So what could happen is, once you connect this hydrogen electrode, this is your hydrogen electrode, to any metal, possibility could be that on this hydrogen electrode becomes the cathode, and the metallic system or the metallic electrode becomes the anode. Anode means the metal is dissolving it, or getting dissolved in its own solution, and evolution of hydrogen gas is taking place due to the utilization of 2 electrons. So in this case, metal is your acting as the anode. Now if you connect another metal with the same hydrogen electrode, so the standard, before we begin with this, the other example, standard electrode potential, it is written in this form: V, the name of the metal, and you have a subscript O, is less than 0. So the electrode potential, you assume that the hydrogen electrode has a potential of 0. Standard hydrogen electrode, arbitrarily chosen, has the potential of 0. In this case, where metal becomes the anode, the potential of metal would be less than the standard hydrogen electrode. In another case, it could be a possibility that the metal becomes the cathode, ion gets start depositing on the metal surface, and H2 gets converted into H plus ions. In this case, the potential of the metal would be greater than the platinum or hydrogen electrode potential. Is this clear to you guys, the process? Gee, is there any confusion?
ये सर ये क्लियर है सर, जरा पिछली स्लाइड पे जाइएगा
जी
सर। ये जो आपने वजह बताई थी कि Fe2 में जो है ऑक्सीडेशन क्यों अकर होती है और Cu+2 में ये जो है इसमें रिडक्शन क्यों अकर होती है, इसकी रीजन जो है आपने बताई है कि इलेक्ट्रोड पोटेंशियल्स होती है स्टैंडर्ड। तो सर वैलेंस इलेक्ट्रॉन्स जो है ना वो इसमें क्यों रोल प्ले नहीं करते सर?
वैलेंस इलेक्ट्रॉन्स रोल नहीं प्ले करते, देखे ना, you have 2+ electrons that are released as a result of Fe getting into Fe2+. Those electrons are consumed by copper 2+. So electrons तो consume हो गए, वैलेंस इलेक्ट्रॉन्स कहां से आप लेके आ गए? वैलेंस इलेक्ट्रॉन्स का ताल्लुक क्या है?
सर इसमें भी लॉस ऑफ इलेक्ट्रॉन्स और गेन ऑफ इलेक्ट्रॉन्स होते हैं ना? तो
जी
सर इस तरह नहीं हो सकता कि मतलब जो है ना लॉस ऑफ इलेक्ट्रॉन से ऑक्सीडेशन अगर होती है और
सॉरी
सर
सॉरी
इसी सर मतलब कि लॉस ऑफ इलेक्ट्रॉन्स और गेन ऑफ इलेक्ट्रॉन्स इसमें भी होता है ना।
जी जी
तो फिर सर यही तो मतलब मैं कहना चाह रहा हूँ कि फिर इसमें तो वैलेंस वैलेंस इलेक्ट्रॉन्स जो है ना वही उनको रोल प्ले करना चाहिए ना।
नहीं, मेटालिक सिस्टम में आप देखें ना इलेक्ट्रॉनिक क्लाउड होता है। वैलेंस इलेक्ट्रॉन्स तो एक
अच्छा
एटम
यस
की हद
सर।
तक बात ठीक है, लेकिन ये तो आप बात करें इलेक्ट्रॉनिक क्लाउड मौजूद है, उसमें इलेक्ट्रॉन्स तो मौजूद हैं, लेकिन द क्वेश्चन इज कि विच ऑफ द मेटल्स वुड essentially be giving up the electrons और कौन सा कंज्यूम करेगा। ये टेंडेंसी आप डेवलप करते हैं यूजिंग दी ईएमएफ सीरीज। आप हर इलेक्ट्रोड को टेस्ट करते हैं अगेंस्ट द स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड, जिस तरह मैंने अभी बताया, और आप रेट करते हैं कि वेदर with regards to the standard hydrogen electrode जिसका potential zero है, is it having a positive potential, that means is it cathodic or having the inert nature, or is it having a negative potential, in other words is it having an anodic nature? You're getting the point?
यस सर।
अच्छा, अब वो होता किस वजह से है कि कोई एटम जो है वो कोई कोई एलिमेंट जो है ज्यादा एनोडिक है ज्यादा कैथोडिक है? दिस कुड बी ड्यू टू मेनी फैक्टर्स। इलेक्ट्रॉनिक स्ट्रक्चर क्या है, एटम्स में एलिमेंट, वो एलिमेंट में टोटल एटम्स इलेक्ट्रॉन्स कितने हैं, नेचर में किस फॉर्म में एग्जिस्ट करता है, देयर कुड बी मल्टीपल फैक्टर्स। स्ट्रक्चर क्या है उसका, क्रिस्टल स्ट्रक्चर क्या है। तो वी आर नॉट डिस्कसिंग व्हाई इज इट हैविंग एनोडिक और कैथोडिक नेचर। our interest is with regards to each other, which of the two uh, metals would have a cathodic behavior and which would have an anodic behavior. Clear? If connected together, this is the point of interest.
यस
Acha. Now we have developed this EMF series, and remember that we have written every reaction in the cathodic form. In all, this is the cathodic form, taking up electrons, converting into zero. Reduction reaction, a reduction reaction, consuming the electrons. So we have written down all the reactions in the reduction form. Now, just by looking at it, it says that metals with smaller standard hydrogen potential would corrode. For example, if I connect chromium with zinc, obviously in their own 1 molar concentration solutions, what do you think? Which of the two would become an anode and which of the two would become the cathode?
जिंक एनोड बन जाएगा, क्रोमियम
Very good. Since
cathode।
zinc is more negative, zinc would become anode and chromium would become cathode. So this is the this is one way of looking at it. Another way is how to check the spontaneous nature of a reaction. What you do is that, let's say if you have nickel and cadmium connected together, you assume any one of them as the cathode. Let's say I assume uh, cadmium as the cathode and nickel as the anode. This is my assumption at the moment. So I'll take the potential of cathode, standard potential, minus the potential of anode. So I'll have this figure over here and this in the bracket, and whatever the answer comes, if it is greater than zero, that means your assumption was correct. But if it is less than zero, that means your assumption was incorrect. Reaction would not take place in the direction that you have assumed. It would take place in the opposite direction. Is this clear to you guys?
Yes, sir.
So
यस सर।
the cell potential is calculated V cathode minus V anode, and if it is greater than zero, that means your reaction would take place spontaneously. If it is less than zero, that means the reaction would not take place spontaneously. All right. So we'll stop over here.